In today's math lesson, we're going to find the slope from 2 points. So what's happening in this lesson is that we find that we are given 2 coordinate points. There's no graph here. And we have to walk through the use of these 2 coordinate points very carefully. The first thing that's going to happen is that we're going to label the 2 points with their x and y parts. What does that mean? What does that look like? That looks like each coordinate point is always x and then y. And you can say very simply that the first coordinate point you were given is point 1. So it's x1 and y1. And the second coordinate point that you were given is point 2 with x2 and y2. So this is how you label them. The second step is to look at your formula and fill it in using the 2 coordinate points that you were given. And it is very important that you fill in this formula correctly. You have to put the appropriate numbers where they go. So we're filling in the blanks, but we need to know where they go. Remembering that slope is given to us, it's understood, it's symbolized with the letter M. So the formula that we will be using is y2 minus y1, all divided by x2 minus x1. It is important that you keep the order of 2 minus 1 over 2 minus 1. It is important that the y values are on top and the x values are on the bottom. So I really cannot stress enough how important it is to keep the order as you fill in the formula. If you switch the numerator or the denominator from being the second one minus the first one to being the first one minus the second one, you will end up with the other sign. What was supposed to be a positive slope will now appear negative, or vice versa, with what was supposed to be a negative slope now appearing to be positive. And that's the difference between right and wrong. So it is important that you are attentive and careful to the order that you place your numbers into the formula. Example 1, find the slope of the line that passes through the points 9, 1 and 1, 10. Let's walk through the steps in the introduction to find the slope of this line. Our first step was to label the given points, and we're going to do exactly that. So points are always in the order of x and then y. The first point given to us will be point 1, so it's x1, y1. And the second point given to us is point 2, so it's x2, y2. Now that values are labeled, let's set up our formula. The slope formula is always a fraction with minuses subtracting in the center. So these minuses, they're going to be there. And I do encourage students to draw the dividing part of the fraction, placing subtractings in the middle before we put in any numbers, so that if your values are negative, you don't accidentally forget to bring one along for the problem-solving process. y2 minus y1, we have x2 minus x1. Let's place in our numbers and see what happens. y2 has a value of 10, y1 has a value of 1. x2 has a value of 1, and x1 has a value of 9. We have now placed our values into the formula appropriately. We can go solve and simplify and determine the slope of our line. Let's do that. 10 minus 1, 9. 1 minus 9, negative 8. Being that one never leaves a negative sitting on the denominator of a fraction, you simply either bring it out in front or place it up on the numerator. That means the exact same thing either way. 9 over 8 does not reduce. Therefore, the slope of the line connecting these two given coordinate points is negative 9/8. And there you go. Example 2 asks us to find the slope of the line that passes through the point 2, 2 and 10, 7. Let's start this process by just simply labeling our coordinate points as they are always first x and then y. Our first point, point 1, x1, y1. Our second point, point 2, x2, y2. It is always helpful to have your formula written off to the side, someplace close by for you to see it so that you know exactly how to set it up and fill it in. Let's do that now. Our slope, m, as it is always m, setting up my dividing fraction bar with the two minuses in the middle so that I know exactly where to space out my numbers. We have a y2, a y1, an x2, and an x1. Let's place in our values. Y2 has a value of 7. Y1 has a value of 2. X2 has a value of 10. X1 has another value of 2. Now that we have set up our fraction, define the slope, let's actually get an answer. 7 minus 2 is 5. 10 minus 2 is 8. If you check this in a calculator, you will find, nope, it does not reduce. And there you go. Our final answer of the slope of the line connecting these two given coordinate points is 5/8. In example 3, we're going to find the slope of the line that passes through the point 5, 7 and 3, 8. Starting things off, let's find out what the parts of our coordinate points are by labeling them with x and y, recognizing we have point 1 and point 2. Remembering that keeping your formula close by so that you fill it in correctly, let's do that now. Our m, our slope of the line, set up with our dividing bar fraction and minuses in between the terms, the values, the numbers that are going to be used. We have y values on the top as shown in our formula. It's y2 minus y1. My y2 value is 8. My y1 value is 7. x2 minus x1 on the bottom. Our x2 value is 3, and our x1 value is 5. Let's go ahead and subtract and start finding out what the slope of this line actually is. So we end up finding that this 8 minus 7 is 1. 3 minus 5 is negative 2. As we saw in example 1, you are never allowed to call it a day and be done with it having a negative in the denominator of a fraction. That's just not going to work. And we discussed in example 1 that you can either bring the negative all the way up to the numerator, or you can place the negative out in front of the fraction, and that is just fine either way. So we find that the slope of the line connecting our two given points happens to be that of negative 1/2. And there you go. In example 4, we're going to find the slope of the line that passes through the two given points, 9, negative 62, and 97 with negative 60. As always, let's begin by labeling our coordinate points with their appropriate x and y values. And we know that the first point is always point 1, and the second point is always point 2. While truthfully you don't have to memorize what the slope formula is, it is hopeful that you'll do it enough times that it just comes naturally to you. That is the hope. But if not, you can always go back and make a reference to it. Let's see. y2 minus y1. That starts us with a negative 60 minus negative 62. This is why it is helpful to put your minuses in position with your fraction even before you put in the number values, because you don't know if there's going to be minuses that appear in the working process, and we don't want to get thrown off. x2 minus x1, so 97 minus 9. Let's do our subtracting and see what we get. We know that a negative and a negative side by side make a positive. And that means that negative 60 plus 62 is a positive 2. While 97 minus 9 is 88. If possible, and it is, reduce. It is necessary, it is expected. So 2 over 88, 2 88ths is going to be 1 over 44. So the slope of the line given to us is 1 over 44. And there you go. On our fifth and final example, we're going to find the slope of the line that passes through the points 8, 3, and 2, 10. Starting this process, we label our points. It's a really simple thing to do, and many people don't think it's important, but I promise it will help you to avoid so many mistakes if you will just take a moment to do that. Now that we have our formula as our reminder, let's go plug in our points. y2, 10. Minus y1, 3. x2, 2. Minus x1, 8. Let's go subtract and see what we get. 10 minus 3, 7. 2 minus 8, negative 6. And as we have already discussed multiple times, negatives can only be on top of or in front of a fraction. So truthfully, just for display purposes, you could write that this is negative 7 over 6, or you could write that this is negative 7/6. Either are correct, either are perfect and right and would be completely acceptable. So there you go.